This video is part 2 of our conditional loops lessons. We're going to go over example number 1 from the note. So let's go over example 1. It's going to use a loop to count. We're going to create a program called loop example 1. In it we're going to add a label called LBL counter and a label called LBL start. When the user clicks on LBL start, we're going to count through the numbers 1 to 9,909 in LBL counter. You can see here that I actually already have the code that I'm going to write in, but let's do it together. So let's create a new project. I'm going to go over to my USB key. D drive. And I'm going to call it loop example 1. Now if yours is done before mine, what I'd like you to do is to add in a couple labels. The first label is going to be called LBL start. The second one's going to be called LBL counter. For the label LBL start, I'm going to change the text to say, click here, to count from 1 to 9,999. Now for the LBL counter, I'm actually going to erase the text. And I'm going to rename it here. Now if I want this label to have a click event, I'm just going to double click on it. It's going to create a new subprogram called LBL start underscore click. This is because of the name that I've given to my label, and this is describing the event that will happen when this code runs, or the event that needs to happen for this code to run. So what I'd like to do first of all is create a variable to count. So for counting from through the numbers 1 to 9,999, I'm going to use an integer variable. I'm going to document it first. Used to count from 1 to 9,999. It's an int variable, and I'm just going to call it counter. And I'm going to set the starting value to equal 0. Now for my loop. If you recall from our previous video or earlier in the lesson, if you're watching these together, you'll remember that we learned how to create something called a do-while loop. And it's called a do-while loop because it's got these two keywords, do and while. Now, I want my loop to run while the counter is less than or equal to 9,999. And each time I repeat, what I'd like to do is I'd like to print out to my label. So I'd like LBL counter.text to equal counter. And since counter is an integer variable, I'm going to have to change it to a string before it can be printed out into my label. And in addition to printing out the counter, I'd like to add 1 to my counter variable. So I'm going to use counter equals counter plus 1. And my documentation just says that I'm going to add 1 to the counter each time the loop repeats, so it will go up, will count up from 1 to 9,999. So this is pretty much everything I need for now. I'm just going to run my code here. So I've programmed this label. I'm going to click on it and sort of freezes for a little bit here. I'm not sure if I clicked on it. There we go. Okay. And we have to wait a little bit to see that 9,999 does appear, but you'll see that actually didn't really count. Okay? So it just sort of went from nothing to 9,999. So there is a problem there, because I actually want to see it counting. And let's just go over what we talked about previously about the program freezing. So this usually happens when there's a loop running code and there's no feedback. There's no messages for the user to see that something is actually running, and so the user might actually think that the program has completely stopped running and that they won't get it back. And so sometimes they'll wait, so other times they'll probably just Control Alt Delete and get out of there. So what I'd like to do is give a little bit of feedback for the user. And so in order to do that, what I'm going to do is I'm going to add this application.doEvents command into my loop so that each time it runs the loop, it unfreezes. So I'm just going to add that right at the bottom over here, application.doEvents. It's a subprogram call, so I'm going to add these two round brackets at the end of it. And now I'm going to run my code. So click here to count from 1 to 9,999. Click and there you are. Okay, so you can see it counting up, and hopefully it stops at the right time. 9,999. There we go. Okay, there's actually a few issues here with my code that I'd like to go over. First thing is that I don't have documentation for my loops. So remember that documentation for the for all of your code blocks actually counts for communication marks. So here I'm just going to explain that it's going to count from 1 to 9,999 and print it out in the label. The second thing is actually that it doesn't really count from 1 to 9,999. So let's go over the code here. Whenever I click on my button, it's going to jump into this subprogram. And the first thing that it does is that it sets counter to equal 0. Then it prints out in the label 0. Well, I wanted this thing to actually start running at 1. So I'm going to just change this up to counter equals 1. And that will fix that bug. And so now when I run my code, instead of counting from 0, it's going to start counting from 1. Now you don't actually get to see that because the computer is so fast, but that's just something that I'd like to point out, that you don't always want your variables to start off at 0. Please start off your variables with a value that actually matches what you say you're going to do. So that's the entire program here, and we can change it to count from 1 to 999 if you want to run a little bit faster. It's going to be a lot quicker here. Okay, and you can make it count up to a million if you really want to, or more, and it would only change a small change. It would only require a small change to the loop condition. So here's some tips I'd like to give you when you write your loops. This sort of works for all of them. First of all, you should declare your variables outside the loop unless you want them to be reset every time the loop repeats. Sort of makes sense, I guess. If we had declared counter inside of the loop, say instead of here, we declared it inside, we'd have a problem. Well, there's a problem right now that two variables with the same name are declared in the same scope of the program. But you can see here that this is going to cause a problem. Each time it repeats the loop, it would reset counter to equal 1. And so actually it would never equal 999. Counter would equal 1. It would count 1 plus 1 is equal to 2, so counter would equal 2. Then it would repeat the loop and counter would be reset to 1. And so you get stuck in something called an infinite loop. And at that point the program actually sort of would freeze up from the user's point of view, because nothing really seems like it's happening. So let's just get rid of that, because that's actually an error. Second thing is, if you have an error saying local variable unassigned, make sure that you give the variable starting value. For example, int x equals 0 assigns the value of 0 to x. So, I mean, normally a variable declared inside of a subprogram actually doesn't have a value, so we'll get an error right here. Use of unassigned local variable counter, you can see that in the message that pops up. And so we can easily fix that just by assigning a value when we first create it. The last thing that's important for us right now is communication marks. And in order to get those communication marks, we should be documenting all of our loops. So before the loop is where I'd like to see it. Explain what the loop does and when it exits. So count from 1 to 9,999, so sort of explains what it does, and also sort of explains where it exits by saying that it just sort of stops at 9,999. So that's our second part of the conditional loops lesson. In our third part, we'll be talking about the while loop.